Hello, my name is Karen Milanya and I will be talking about dibromochloropropan, also known as DBCP, and its contamination that occurred in Lathrop, California. I will first start off with the purpose and objectives of this presentation. I will then go over the compound DBCP and what it has to do with the Occidental Chemical Company in Lathrop, California. Following this, we will explore the impacts of DBCP at Occidental Chemical Company and any future implications of the compound. Finally, I will give a summary of the findings. The purpose of this presentation is to give an overview of the compound DBCP and what this has to do with the Occidental Chemical Plant in Lathrop, California, as well as provide the effects of continued use of DBCP by workers at the Occidental Chemical Company. We will also examine any future implications due to the continued use of DBCP. What is dibromochloropropan? DBCP is an organic compound that is a dense, colorless liquid, although commercial samples often appear amber or even brown. DBCP is a compound prepared by bromination of allyl chloride at ambient temperature. Either alone or in formulations, DBCP was widely used as a soil fumigant for the control of nematodes and root knot disease. Application was made by direct injection into the soil or addition to irrigation water. DBCP was introduced into agriculture in the USA in 1955 and later approved as a fumigant in 1964. DBCP is a pesticide that was found to be effective in getting rid of nematodes that were destroying bananas, pineapples, and other tropical fruits. So, what does this have to do with the Occidental Chemical Company? Well, the Occidental Chemical Company operated a fertilizer and pesticides plant in San Joaquin Valley in Lathrop, California, and began operations in 1953. The main task of the workers was mixing up batches of DBCP that were brought over from manufacturing reactors. The workers added solvents and emulsifiers to the dried DBCP, transforming it into an amber liquid. It was then measured into cans and stacked in the warehouse for shipment. In the fields, the pesticides were either pumped directly into the ground or sprayed into the air with irrigation guns. Occidental Chemical Company came into the limelight in 1977 following allegations that a substantial proportion of the workers at the plant had become sterile as a result of handling the compound DBCP. But before we delve into the issue of sterility, let's briefly examine some impacts of DBCP. As we know, there are several impacts involved with the use of any chemical compound. The potential environmental impacts include biodiversity loss. The visible social economic impacts include lack of work security, labor absenteeism, unemployment, loss of livelihood, or even potential violations of human rights. The health impacts, which form the basis of this presentation, include sterility in male workers, as well as alleged cases of cancer. So, back to our sterility story. In 1977, workers at Occidental Chemical Company noticed that they were unable to have children. This made this case in Lathrop, California, the first major episode of worker infertility related to DBCP. As a result, studies were conducted to determine whether DBCP was a causative agent in these findings. Here, we see the visual illustration of the population at risk and the study population. The population at risk at the time was determined to be 310 workers. 261 or 84% of these workers were paid hourly workers. 34 or 11% were salaried employees, and 15 or 5% were others, that is, applicators, setup men, or even contract drivers. Of this population, 196 male workers, that is 63% of the population at risk, were examined for the study. From Figure 3, we see the distribution of sperm count among workers exposed to DBCP and those not exposed. The number of those exposed is 107, while those not exposed are 35. The median sperm count for those with a history of exposure to DBCP was 45,600,000 per millimeter, while for the non-exposed group, the median sperm count was 78,700 per millimeter. 44% of the workers exposed to DBCP had sperm counts of less than 40 million per millimeter, in comparison to only 11% of those not exposed to DBCP. This difference is highly statistically significant, with a p-value of less than 0.005. From the table, we see a clear increase in the incidence of oligospermia with increased exposure of DBCP. The number of men in the group with exposure with counts greater than 40 million per millimeter was 8 times the number of oligospermic men in the same group. Between 1 to 6 months, the ratio was about 3 to 1. Between 7 to 24 months, it was 1 to 1. And between 25 and 42 months, the ratio reversed such that the number of oligospermic men was twice the number of the men in that category, with counts greater than 40 million per millimeter. After 43 months of exposure, the ratio of oligospermic men to men with counts greater than 40 million per millimeter increases to almost 5 to 1. From this table, we can conclude that oligospermia increases in workers with increased exposure to DBCP. Figure 5 gives us a much clearer visual presentation of these findings. Of the exposed men, 13.1% were azoospermic and 32.6% were oligospermic. In contrast, the non-exposed group included only 2.9% azoospermic and 5.7% oligospermic men. Given this analysis, what future implications are there? 20 years after the ban of DBCP, it continued to be a major problem in San Joaquin Valley. DBCP has been detected in public groundwater sources in several places in California. This poses a big challenge as groundwater contamination by agrochemicals is recognized as an important environmental problem. DBCP is regulated as a drinking water contaminant by the California Department of Public Health. The California state maximum contaminant level for DBCP is 0.2 micrograms per liter. And based on the California Department of Public Health, the red dots we can see on the map show the 364 active and standby public drinking water wells with concentrations of DBCP above the maximum contaminant level. And most of these wells have occurred in Fresno, Stanislaus, San Joaquin, and San Bernardino counties. Remember that the Occidental Chemical Company was located in San Joaquin Valley. Now let us go over a summary of what we have discussed in this presentation. Until 1977, DBCP was used as a soil fumigant and nematode on over 40 different crops in the United States. Human exposure to DBCP could result from ingestion of contaminated drinking water or food through the skin or through inhalation. In the past, release of DBCP to the environment occurred primarily from its fumigant and nematicide uses. The employees of the company at the time of the study were considered to be exposed to toxic concentrations of DBCP, and the workers with exposure to DBCP were more likely to have abnormalities of sperm count than controls. The workers who were exposed the longest were also more likely to have a reduced or zero sperm count. Finally, from the discovery of DBCP in groundwater, there is an illustration that there are still uncertainties of the effects of pesticides and chemicals on health and the environment. The case of DBCP as a pollutant is an indication that pesticides need to undergo stricter tests before being released into the environment. Thank you for listening.